Hi there, Mr. Sutton here, bringing you the IM3 Chapter 8 Quiz 1 review on statistics. For this example, we're trying to figure out the mean, median, and mode of a list of numbers. So for mean, that's just the sum of all the numbers divided by the number of numbers. So let's figure out the sum by adding all this on the calculator. So plug in all that in. Looks like that's going to add up to 117. And now the number of numbers, let's see here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll just divide that, which I can do without a calculator. We're dividing by 10, so just move the decimal left by 1. That's 11.7 for our mean. Now for the median, that's the middle number once the data items are arranged in order. So let's first put these in order. The lowest number out of all of these is 1. And feel free to cross these off on your own as we go here. After that, we've got 4, and then it looks like 8. That's the last single-digit number. Then we've got a 10, and let's see, we've got a 12. After 12, what's next? Looks like we've got a 15, and another 15, a 16, a 17, and no 18s. We've got a 19, though, and it looks like that's the 10 that we had up there. So now that we have these in order, to find the middle item or items, we're going to just cross off pairs of numbers on the outer edges of the data. So we'll do 1 and 19 first, and then we've got 4 and 17, and then 8 and 16, and then 10 and 15. Now there's 2 left in the middle. If you have 1 or 2, you're pretty close to finding the median. If you've got 1, it's just whatever you see there is the one number is the median. If you have 2 numbers in the middle, then you have to average them together or just take the mean is what we're saying here in order to find the median. Because the whole idea with the median is half of your data items need to fall below and half need to fall above whatever that number is that you give. So we've got, let's see, 12 plus 15 over 2. And then that's going to be 27 over 2, which is 13.5. So there's our median. The mode is just the number that appears the most, which is easy to see if you have this put in order. It looks like the only number that's even repeated at all is this 15, so that would be our mode. Now, just theoretically speaking, if no numbers were repeated, if you only saw one of each, then there would be no mode. And if you had multiple numbers that were repeated the same amount of times, like let's say that there was also 2 of these ones here, then you could have 2 or 3 or as many different modes as you needed. But that's only if you have numbers repeated more than once. For this problem, we're applying the idea of mean, median, and mode to a dot plot. So let's first find the mean. Again, that's the sum of all the data divided by the number of data items. So let's find out the number of data items first. We can do that quickly by just counting the number of dots, since each of these dots represents a distinct item of data. So we've got, let's see, 2 here, plus this is, let's see, 2, 4, 6, 8, 10, so that's 12 altogether, plus another 2 is 14, plus another 3 is going to be 17. So when we do our mean, we're going to be doing a bunch of stuff added together divided by 17 for 17 dots. All right, well, what are we adding together? So we've got 2 dots that each have a value of 1, so I'll say 1 times 2 or 2 times 1, however you want to write that. And then we have 10 dots that each have a value of 2. So rather than writing 2 10 times, I'm just going to write 2 times 10. And then we also have, let's see, 2 of these 3 dots. So 2 times 3 we're adding in there. And we have 3 of these 5 dots. So 3 times 5. And adding all this up, let's see here. I could probably do this without a calculator, but then I'm going to have to divide by 17. So I might as well use a calculator anyway. So adding up everything in the numerator on my calculator, that's 43. So we have 43 divided by 17, which going back to my calculator, let's divide that by 17 to get 2.53, because I'm rounding off to the nearest hundredth on this. So that's my mean. Now for the median dot plot style, again, the median, you're finding the middle number. So you want everything in order, and then you're crossing off pairs of numbers on the outer edges until you get to the center. Now with dot plots, it's kind of nice because they're already in order, right? These are all 1s, these are all 2s, these are all 3s. So really we just have to cross off dots until we get to the middle dot or pair of dots. So we've got a 1 over here and one of these 5s. And then we have this one and another 5. And now we move on to the 2s plus this last 5 here. We have a 2, and now one of these 3s is being crossed off. Another 2, another 3. And now it's all 2s. So we've got this 2 and this 2, I guess. This 2 and this upper 2 up here. And then this 2 and this 2. And that leaves us with a single item in the middle. And with median, again, if you only have one item, then that is the median. So that's going to have a value, just looking down here, of 2. And now for the mode, we want to see which items repeated the most. With dot plots, you're just looking for which one of these has the most dots, and that is 2. For this one, we're trying to apply mean, median, and mode to a stem and leaf plot. So starting with mean, we're going to first figure out how many items there are, and then we're going to divide the sum of all the data by the number of items. So to figure out the number of items, really we just have to count the leaves, because each one of these leaves represents an individual data item. So we've got, let's see, 6 plus 3 is 9, plus 4 is 13, plus 2 is 15, plus another 1 is 16. So we're doing something divided by 16 for the mean. Now for the sum of all the data items, there's a few things going on here. For one thing, well, we've got reading the stem and leaf by itself, right? If I have a 1 for the stem and, say, a 5 for the leaf, that really means I have 15. But there's a little bit more going on as well, because instead of 15, if you look down at the key, that actually means you have 1,500. So whatever you think you have by reading the stem and then the leaf, on this particular stem and leaf plot, because of what the key is saying, you have to multiply whatever you think you have by 100. So we're going to start by writing down all the data items, and then we'll add them together. I need to know what I'm adding before I add anything. So to make this a little bit easier, since I have to multiply what I think I have by 100 each time, instead of having all those zeros written out, I'm going to save myself a little bit of time by taking a 100, opening a parentheses, and then just writing down what I read directly off my stem and leaf plot here. So I've got a 0 and a 1. That just represents a 1. I've got 3 of those, in fact, so I'll just write 3 times 1 in there just to save a little bit of space. And then I have a 0 and a 3, so that just represents a 3, a plus 3. Now, this really means 300, but I've got this 100 outside this parentheses to keep track of that. Next, I have a 4 plus a 9. And now I move on to a stem that's not 0, so I actually have to pay more attention to the stem now. So I have a 1 and a leaf, a stem of 1 and a leaf of 1. That's an 11. And again, we know that really means 1,100 in this case. And then we have 1 and a 5, so that's 15. And then 18. Moving on to the stem of 2, we have 24, 25, 29, and we have 2 of those. So I can write 2 times 29. And then down here we have 33, 38, and finally 41, and I'll close that parentheses off. So let me add all this stuff in the numerator now. I'm about to enter the whole numerator into my calculator. Just before I do this, I wanted to show you, because it'll probably get cut off when I've got it all entered in. Notice again that I'm opening that 100 with a parentheses in the very beginning. Very crucial to do that. All right, let me enter the rest off camera. So there's the tail end of all of this stuff over here that I was entering. Pressing enter on that, we've got 28,200. It's a big number, and we're still dividing that now by 16. I'll go back to the calculator for that. Let me just press divide, and it'll divide my answer now, and I'll put 16 in there to get 1,762.5. Great. So that's our mean for this one. Now for median, that's the middle item when everything is put in order. With a stem and leaf plot, like most of the data structures you've seen, everything's already in order. Notice the stems go from smallest to greatest, and the leaves on each stem go from smallest to greatest. So since it's already in order, when we cross things off, we're just going to cross things off directly on this stem and leaf plot itself. So I'll start by crossing off the highest and the lowest and the highest items. So we've got 1 and 41 getting crossed off. And then I'll just keep doing that and work my way in. So we have a 1 and a 38, this 1 and the 33. Now we have a 3 and this is 29 right here, 4 and the other 29, 9 and the 25, and now we've got 1 and 24, and that leaves us with 15 and 18, which again we know represents 1500 and 1800. So with two items in the middle, that means I have to average them together. So we have 1500 plus 1800 over 2. That is, you could use a calculator if you wanted, but I know that's 3,300, half of which is 1,650. So there's our median. Now for mode, we want to see which items repeated the most. So let me look for a leaf that's repeated more than once, right? So we've got these ones. There's 3 of those. So that's the winner so far. And if you look through here, the only thing that ever gets repeated is this 9 right here, and that only gets repeated twice. So 1 is definitely the winner. That's going to be our mode. But careful, because again, this isn't really 1. This is 100. So that's our mode. For this problem, we're trying to apply mean, median, and mode to a frequency table. So this table apparently is dealing with length of book titles. So we've got all these different books represented by the frequency here. If you added all these together, it would give you all the number of books that you have. And then we have the number of words per book. So for the mean, we need to add up all the words in all the books, so the sum of the data, and divide it by the number of data items, which again is the number of books. So to do that, first let me figure out how many books we're dealing with, the number of data items. I think that's going to be the easier of the two things to figure out. So we just have to add the frequencies to get the total number of items. That's going to be 3 plus 8 plus 1 plus 1 plus 3. So that's the denominator when I'm finding the mean. And I'll actually crunch those numbers in a minute. But let me write an expression for the numerator now. This is the sum of all the data, which in this case is just saying how many total words do I have over all these books. So we have 3 books, each with 1 word in the title. So that's 3 times 1, I guess you could write, or just 3. And then you have 8 books, each with 2 words in the title. So that's 8 times 2, or 2 times 8, 16 words there. And then you just had 1 book with 3 words, and we had 4 words for this other book, and then we have 5 words for 3 of these books. So that's 5 times 3. Now let me just crunch these numbers, and I'll do it on the calculator. I'm probably going to have to use the calculator when I do the final division anyway. So firstly, we've got the numerator, which comes out to 41. Now for the denominator, I could probably do that without the calculator. So the 3 plus 8 is 11, 14, no, not 14, 12, 13, 16. There we go. Maybe I should have used the calculator. But that comes out to 16. And then we have 41 divided by 16. For that, I will definitely use the calculator. So divide my answer of 41 by 16 to get, rounding off to the nearest hundredth, this is 2.56. Average number of words in a book title based off of these books. Now for the median, this one's a little trickier. Again, this is the middle item when you arrange all of the items smallest to largest. So if you were actually writing all of these out, you would have a 1, a 1, a 1, and then you would have 8 of these 2s and 1 of these 3s and so on and so forth. But rather than write it all out, I mean we could, there's not that many items, but rather than write it all out, we're just going to figure out the item number of our middle item. And to do that, a little trick you can use is just add 1 to the number of items, which is 16 in this case, and divide by 2. So 16 plus 1 over 2, that gives us a median item number of, actually this comes out to 8.5. So item number 8.5 is the median. Now that's kind of weird conceptually to think of that, but if you figure out which number this falls within, which of these categories here it falls within, that category is going to be the median. So to figure out where this falls, let's just start adding these frequencies together to figure out how many books we've stacked next to each other. So we first take a look at these first 3 books that each have 1-word titles. So that's 3 books we've stacked up so far. And then we have these 8 books, each of which has 2 words in the title. So after we add in these 8 books, that brings us to a total of 11 books. Now, in the process of going from 3 books to 11 books, we have passed book number 8.5. So that means our median is located somewhere within this range of 2-word books. which means that our median is just 2, because you want the category number. Now for the mode, you're looking for the item that's repeated the most, and for that with frequency tables, we just look for the category with the highest frequency. In this case, that's this 8 right here. Nothing comes even close to 8 in our frequency column, so the mode is also then going to be 2. For this one, we're trying to make a box and whisker plot from this data. So when you're making a box and whisker plot, first thing you want to do is sort your data so that you can easily pick out the median and then the lower and the upper medians. So sorting this out, our smallest number out of the list is 87. After that, we have an 88. And I think that's it for the 80s, so we move on to the 90s. So we have a 91, and actually we have another 91 as well. After that, the next highest number is 93, followed by another 93. Again, feel free to cross these off as you sort them and write them down. And then finally, we have a 95 and a 96. So we started with 8 items, we wrote out 8 items, we're good. Okay, let's pick out the median of the whole data set now. So if you were to cross off your numbers and get to the middle, there's 2 numbers in the middle, 91 and 93. So that means we have to average them together to get the median, or just pick the number that's directly between them, which is going to be 92. And that splits our data into 2 halves. We have to find now the median of the lower half and the upper half. So for the lower half, that's these 4 numbers from 87 to 91. There's 2 middle numbers for that set. So we need to average 88 and 91 together. And let's see, that's going to come out, if you do that, to, I believe, 89.5. It's basically halfway between 88 and 91. And then we have to do the same thing for the upper set, the upper half of the data, from 93 to 96. So the 2 middle numbers there are 93 and 95. Middle number between those, the median of those, the mean in this case, is going to be 94. And this gives us enough to draw our box and whisker. So we're going to start by making a number line. Now when you're constructing your number line, just make something that it's easy to plot out the minimum, the maximum, and these 3 medians that you found in between. So use whatever numbers and grid line increments you need to make this easy for yourself. In my case, I went from 85 to 96 going by ones, but you certainly could have picked a lot of other things here. So I'm going to start with the median of all the data, the 92, and I'll put a little vertical line right there. And now from there, I'm going to grow my box. So my left box is going to extend out to my lower median here to 89.5, which is right here. And my upper box goes to my upper median, which is 94. So that's over here. So I'm going from 89.5 to 94, drawing 2 boxes like so. So 89.5 and then 94, there we go. And this represents the middle 50% of my data. Each box is 25%. Now to get the other 50%, 25 over here, 25 over here, we draw in the whiskers. And those go out to the minimum and maximum data items in our list. So we have the left whisker going out to 87 back here, and the right whisker going to our max at 96, which is over here. So from 87 to 96, there's our 2 whiskers, and this is our box and whisker plot. For this example, and in general, when you're trying to identify the median, min, max, and interquartile range based off of a box and whisker plot, here's how we proceed. So for the median of all the data, you just have to look for that middle vertical line in your box. So this right here is going to be our median of 16. For the min, the minimum, that's the left whisker, which can be drawn as either a dot or a vertical line. In this case, they use dots. So the left dot here is 13. That's our minimum value, the smallest item of data. And then for the max, that's the right whisker, which is going to be this 23 in this case. For the interquartile range, or IQR for short, that's basically asking how long is this box? You know, what's the range of the middle 50% of the data? So to find that, you just have to do the upper median minus the lower median from box to box. So our upper median was 17.5 in this case. The lower median, it looks like, was 13.5 if we're estimating. So we subtract those, and then that comes out to an IQR of 4.